Alrighty, section 3.1, exercise 48. And this again, another technology one. And they would like us to work with f of x equal 1 over x squared plus 1 on the interval 1/2 and 3, closed interval. And they would just like us to find the maximum of the third derivative. Okay, this is why technology is a kind of a nice thing here is, yeah, if I start, this is a quotient rule kind of thing, or I could write it as x squared plus 1 to the negative 1 and do a chain rule, but it looks like it's going to get ugly in taking that derivative. And so here's a nice case where if we go to Desmos, now we won't know what the derivative is in this case, but if we say f of x is equal to 1 divided by x squared plus 1, we get that nice picture. And again, we're just looking on 1/2 to 3. But what's nifty is I can go here and say, okay, I want f, and then 1, 2, 3 primes, like that, and come back here and say f triple prime of x, and there we have the third derivative plotted, and we want to look between 1/2 and what's the 1/2 and 3. Now, you know, I can see, so we actually want the absolute value, and so I should have probably, let's go back in here, and I will come back over here and do absolute value. Oh wait, okay, I guess I can do it at the end, like that. No. We'll go, we'll see if I can make this work with an absolute value. We'll try it. May have to retype things. There's an absolute value. Oh, great, it did it. And come over there, absolute value sign, and awesome. Now we have the absolute value of that third derivative, and we can see that between 1/2, well, you know, there's a good question. You know, what, oops, gosh, what is it at 1/2? It's up here. So, it, you know, at 1/2, it looks to be somewhere in there. Well, you know, it's kind of hard to figure out exactly. So what I'll do is I'll go back in here and go to the beginning and just say, oh, well, let's call this g of x equals, and now let's look at g of 1/2. G of 1 divided by 2, and come out here and close that off, and you see we get our 3.6864. Okay, so and that's all they wanted, was for us to determine that, and so I guess we have it there at 3.684. Now, Sage Cell, this, let's kind of see how this works here. So I'm going to put in, I'm going to declare a symbolic variable by saying var, and I need to go to symbols here, open parenthesis, I need a single quote, and I'll say x, so I need to come back here to x, and go back to a single quote and a close parenthesis, so, and then hit enter. So there I have a variable that way. Then I'm going to define f just as f like that, and then equals. And what was our function again? It was 1 over x squared plus 1. And so I'll do 1 divided by. Now I need to use parentheses here, so that. And to get my x squared, I'll need an x here. And then I need the caret, which is that little pointy thing there, squared. And then plus 1. So 1 divided by, oh, I don't want that divide symbol. I'm so silly. Ooh, can I arrow? Maybe I can click. Yep, okay. Try to click beside it. There we go. Backspace. I want the slash. I don't know. They have that divide sign. I didn't want that divide sign. That would be silly. Okay, so there I've defined f to be 1 over x squared plus 1. Hit enter. And now what I'm going to do is define f prime, fp, equal, and we'll try this once to see how well it works here, equal to f dot diff for taking the derivative, or the doing a differentiate, so diff, and then open parentheses, whoops, I'm not sure, I've noticed it does that, it on my thing it does that, hopefully on others it doesn't do that. Diff with respect to what? Well, x, and then close parentheses, it may jump out there again, no. So I think we have that, and then now it's not going to show me that, so I need to tell it to show me that derivative. So show, now I'll do my open parenthesis, it'll jump out there again, so I'll have to fix that. Show FP, and we'll try that. Now I need to, how do I get rid of this thing? What's that? I don't know what that is. I don't know what I just did. Okay, so I'll hit evaluate. Now it goes away. Oh, am I not connected? No, it says I'm connected to the internet. Loading. Yeah, this may be a bust. So I'll see if I can do an add-on video to come back and finish this up. So we'll cut this video here, but the idea is that we could compute our first derivative and then the second and third and so forth using this. So we'll see if I can get another video that'll show that.